And I really appreciate you guys welcoming us to your family, the Prader-Willi family. It's been kind of a whirlwind since September of 2016 when we got to meet Dr. Schaaf and found out that our daughter was diagnosed with Schaaf-Yang 2.5 years into her life. So we're still in the unknowns and very excited to also have a table of family that came from different states to be a part of this and to be a part of the group out here. So when Emma was first diagnosed, we were like, what is Schaaf-Yang? I'm going to have to get on the internet and find out right away. And Dr. Schaaf was right within a day, contacted us and has been just tremendous in helping all of our families understanding what we need to do. And we really wanted to make this an effort to start raising money, and I'm really excited to be a part of you guys and the team. I'm very excited to have Dr. Schaaf by our side. So he's been amazing and wonderful, and I can't wait to keep growing and finding out more research. So with that, I get to introduce Dr. Schaaf, and I'm excited for him to talk about Schaaf-Yang Syndrome and the similarities and what we have to learn and what we can do to help our children and live their everyday lives as they grow. So, Dr. Schaaf. I got a little emotional.
Dino, should I turn this one off and use this mic? Oh, okay, good, okay. So let me just pull up my slides. Okay, good. And so it's a tremendous pleasure to be here. I've been to one or two of these FPWR family meetings before, and I always learn a tremendous amount, not just from the scientific presentations, but most importantly from all of you about many things that I need to know about Prader-Willi syndrome, because I never meant to be a Prader-Willi syndrome researcher. Things kind of came serendipitously, in 2012 and 2013. But it's been an amazing experience, and you are an amazing group of families. I love the dynamic that's kind of going on, the spirit that's in the room that everyone can feel, and all the things that you do for your kids and the community at large. I just want to applaud you and thank you for everything that you do. So I'm a medical geneticist at Texas Children's Hospital and Baylor College of Medicine in Houston, Texas. And I think, Kim, you're not the only one in the room who is wondering what is Schaaf-Yang syndrome. Because I think a lot of families here may wonder, we came to the Prader-Willi meeting and now they're talking about yet another syndrome, and how does that even have to do anything with Prader-Willi? So I'll try to explain how we got into this and how these two syndromes are connected to each other, both on a molecular and genetic level, but also on a clinical level, and what each group can learn from the other one. So most of you who've been kind of contemplating about Prader-Willi syndrome for several years have gotten a grasp on this, but it's complicated, and so it's worth spending a minute or two to remind everyone kind of what's going on and what the complexities of this region on chromosome 15 are. So you know that we all have 2 copies of chromosome 15, one we get from mom and one we get from dad. And if someone is missing a chunk of chromosome material in a critical spot that we would call the Prader-Willi syndrome region, on the copy of chromosome 15 that person got from his or her dad, then that would lead to Prader-Willi syndrome. On the other side, if someone was to be born without any copy of chromosome 15 coming from dad, but only having two of mom's copies of chromosome 15, that person would also manifest Prader-Willi syndrome. But it's usually always about a whole piece of chromosome material. So it's something that can be seen by certain ways of chromosome analysis. We can detect this, and actually the test that most of your kids had to get them diagnosed with Prader-Willi syndrome is a test that looks specifically whether and how much of that piece of paternal chromosome 15 is present in the blood cells. So this is illustrated here. These are the two most common causes of Prader-Willi syndrome, either a missing piece of chromosome material on the dad's copy or two chromosomes 15 that come from mom without the presence of a paternal copy of chromosome 15. Now, a question that the scientific community has asked for many years is, within this chunk of chromosome material, what are the genes that play a role that would ultimately lead to Prader-Willi syndrome? Because it's not just one gene. So in this region on chromosome 15, you can see here on the slide, there are multiple blocks that are colored in blue, and then there are those little lines that are also blue. All of this blue chunk is the Prader-Willi syndrome region, and there are several genes that will encode for proteins, and then there are other sequences that will encode for RNA molecules. And the question that the community has asked is, does each one of these genes and RNAs have a contribution to what we see clinically in Prader-Willi syndrome, or is it just one out of these and the others don't really matter? And there have been different levels of evidence. People have created animal models where they took out certain genes or pieces of chromosome material to see if those animals, if you take that piece out, would develop Prader-Willi syndrome features or not. And then we've also studied patients who do not have the typical deletions or uniparental disomy of Prader-Willi syndrome, but there are a few, typically less than a handful of patients who have smaller pieces missing within that locus. And so there's been different kinds of evidence, but a lot of interest has focused actually on the RNA sequences, the SNO RNAs, because there have been a few individuals who had deletions, so missing pieces of the SNO RNAs, and those individuals would also have some Prader-Willi-like features, including the hyperphagia and the obesity. But then it came as a surprise in 2013 when we, as a group, identified patients who did not have any kind of deletions, but they actually had point mutations in one of the Prader-Willi genes. So these are very different kind of mutations because you wouldn't detect them with the regular Prader-Willi test, and I'll go into that in a minute. But these are just single letter misspellings. So in the genetic code, which is like thousands of letters in the sequence of these genes, only a single letter is misspelled in this gene MAGEL2, and it would lead also to a developmental disorder, which we felt at the time had a lot of overlap with Prader-Willi syndrome. And on the right side here, you actually see our very first patient, in a baby picture of our very first patient. His name is Donnie. He came to see me when he was 13 years old, and he had mild intellectual disability. He was slightly overweight. He had low muscle tone. He had autism. He had a history of an undescended testicle and a history of feeding difficulties when he was a little boy, which he then overcame later. And shortly after he was born, he had Prader-Willi testing sent, and it came back negative. But it still left mom confused because the doctors in the NICU at the time told her that he looked very much like Prader-Willi syndrome, but the test was negative, and they didn't really know what else to look for at that time. So when he came to see me in 2013, we did a whole genome sequencing on him, and we identified this point mutation in the MAGEL2 gene, which neither one of his parents had. It was unique to him. And because it was a mutation in a gene that was right in the Prader-Willi locus, and mom was giving this history of Prader-Willi syndrome, it immediately caught our eye, and we were wondering whether this could be the cause of his symptoms. On the other hand, there were Prader-Willi features that we consider typical, like the hyperphagia, and if it's left untreated, would lead to obesity, which he did not have. So one of the questions that we asked was, are there additional patients that we can identify who have mutations in this gene, and what do they look like? And I'll tell you about, the patients that we've identified over the years. But, you can see some of the key features that these kids present during infancy. With the open mouth, that's usually an indicator of low muscle tone. And then the kid on the left, you also see the nasogastric tube that is required for feeding because the baby has severe feeding difficulties. So I kind of alluded to this a little earlier. Why is the Prader-Willi syndrome test negative in these kids? And that is really because the Prader-Willi syndrome test is usually a methylation test that checks for the presence of paternal sequence within this region on chromosome 15q11. And this test obviously comes back normal in these children because the sequence is there and it comes from dad. There's, they have a chromosome 15 from mom and a chromosome 15 from dad. It's all there. The only issue is that there's a misspelling of a single letter within the sequence. So you need a different kind of test to identify this misspelling. Instead of a chromosome methylation-based test, you actually need a sequencing test that will read the genetic sequence and will identify the misspelling in the MAGEL2 gene. So in 2013, we identified 4 individuals, and that was our first publication. And that got, a lot of interest, and I think that was also the time that I was first invited to give a presentation at the FPWR meeting on Long Island at that time. But it was really unclear whether this was just, kind of a fluke, a few patients that have some overlap with Prader-Willi syndrome, or, how this would turn out in regards of like the magnitude. So I think a lot of us, including myself, have really been surprised as to how quickly this has developed and how many individuals have been diagnosed with these exact mutations. They're all the same kind of mutations. They're truncating mutations in the MAGEL2 gene just over the last, it's actually less than 4 years. So to this date, we've identified more than 100 individuals worldwide, and these are only the ones that are known to me. So these are the ones who have gotten in touch with me and sent us emails or have been connected with us through the Facebook page. I'm sure there are many more patients out there, but there are 100 patients around the world who have been diagnosed with this condition. And maybe I should spend just a few seconds explaining why it's called Schaaf-Yang Syndrome. So this is not that I was on an ego trip, kind of, trying to kind of put my stamp on a syndrome. We actually called it Prader-Willi-like syndrome in the first year. But a lot of Prader-Willi researchers gave us a hard time because they felt like you can't call this Prader-Willi-like because, the key feature of Prader-Willi syndrome, which is the hyperphagia and the obesity, is typically not present in these kids. So we didn't know what else to call it, and we suggested to call it MAGEL2 associated disorder. But then we were told that we shouldn't do that because gene names sometimes change when there's like an association that's in charge of naming genes, and if they change it, then the disorder would have a different name. So I said, I don't know what else to call it, and there's an organization at Johns Hopkins University, they called OMIM, and they're in charge of naming genetic syndromes. So they just picked the first and the last author of the initial report, which we had published in 2013, and that was Dr. Yang, who's the director of the exome sequencing lab at Baylor, and myself. And at that time, I didn't really know how to feel about that. But I must say it's been a blessing and it's been an honor for me because I think by having the name on the syndrome, it has made it much easier for me to get connected with these families. It's an automatic tool for recruitment because when a family gets this diagnosis, obviously they go on the internet and they try to figure out who's that Schaaf guy and who's the Yang person. And they find our email address and they connect with us, and that has been a tremendous blessing for me, and I'm really honored to be part of their family. Now, how is Schaaf-Yang syndrome diagnosed? I mentioned that you need some kind of tool that spells out the genetic sequence. Oops, this slide is actually, oh no, here it is. So you need something that spells out the genetic sequence, and you can do this in two ways. So either as a physician, you see that patient and you have such a strong suspicion that this could be Schaaf-Yang syndrome that you just say, oh, I learned or I read that, you know, this is the condition, there are typical features, and I'm going to send MAGEL2 sequencing, which will only spell out the genetic code of MAGEL2, and then that will make the diagnosis. Out of the 100 kids that we have, about 5 or 6 of them have had it done this way. All of the others, you know, obviously barely any physician knows about Schaaf-Yang syndrome at this point. I would hope that, you know, that's different maybe 10, 15 years from now. But at this point, most of them have never heard about this. So they see a patient with a complex clinical manifestation, and because they don't have a great idea, they just send a test which now is, you know, available and paid for by many insurance companies, which is called whole exome sequencing, or they participate in a study that would allow them to do whole exome sequencing. So this means that it spells out the genetic code of all, ideally, all protein coding genes, and MAGEL2 is one of these 20,000 something genes, so it will also get to the same conclusion. So most of the kids we have identified have been diagnosed with whole exome sequencing. And the majority of patients who we are in touch with, they have de novo mutations. So this is very similar to Prader-Willi syndrome. You know, for basically all the families in this room, you know, you do not carry the Prader-Willi mutation, but it's something that happened as a new event, either when the sperm was made, there was a chunk of chromosome 15q11 that got deleted, or there was something that, you know, the sperm and the egg cell had abnormal numbers of chromosomes 15, leading to a situation such that the baby would get 2 copies from mom and 0 from dad. So in the majority of Schaaf-Yang patients, this new mutation is also a misspelling that occurred as a new event at the time that the sperm was made. But occasionally that's not the case. And so there are some dads who have kids with Schaaf-Yang syndrome who carry the mutation. And now you would wonder, why are they not affected? It is because they carry the mutation on their maternal copy of the MAGEL2 gene, and that's the one that's silenced and locked away anyways, so it doesn't really matter to them. But because they carry it, they are at risk of passing it on to their children. So the point that I want to make here is it is not sufficient when someone gets an exome sequencing or MAGEL2 sequencing. It's actually not sufficient to just show that there's a mutation in the gene, but really to be 100% sure, you need to show that this mutation is on the copy of chromosome 15 that was inherited from dad. And there are ways that we've developed by which you can do this. And you know, several labs apply these, but this is something, if you want to be 100% sure, this is something that you should see on the report that testing has been done. Now, you know, the topic of the talk is Schaaf-Yang syndrome versus Prader-Willi syndrome, and what's the relationship. So I also want to talk about the clinical similarities and the differences between the two conditions. So I have here a few pictures of the hands of children with Schaaf-Yang syndrome, and then the pictures of some faces with Schaaf-Yang syndrome. And if I only put this slide up, I would think that most of you in this room would feel this doesn't quite look, you know, like Prader-Willi kids. Neither the hands look like the typical hands of Prader-Willi kids, and the faces also don't. And keep in mind that these are kids, most of which are not on growth hormone, and you know, there's no aggressive management of their food intake. So there are certainly differences. I would say, the hands can really be a key feature, especially in the newborn period, because almost all of the kids with Schaaf-Yang syndrome have very unique hands. They tend to have contractures, so they're not able to fully extend their fingers. And then they have this tapering of the fingers, and sometimes the fingers are kind of bent in a funny way. More than 90% of the kids have that, and with physical therapy and occupational therapy, it gets better over time. But sometimes it's even so severe that they've needed release surgery to kind of release the joints and kind of correct it. On the other hand, the faces, on one hand, you will appreciate that many of these kids do not have morbid obesity. And again, these are oftentimes untreated children. And then there are some kind of unique facial features that we feel are arising as we look at more and more of these children, some of which include kind of bushy eyebrows. Especially the young children have a frontal bossing, a very prominent forehead, and some other subtle features. There are additional common features of Schaaf-Yang syndrome that we see now that we have studied about 100 children. We've come to realize that the majority of boys have undescended testicles, so that's an overlap with Prader-Willi syndrome. More than 50% of children have sleep apnea, which can either be obstructive or central or combined, so that's also something that's commonly seen in Prader-Willi syndrome. Eye abnormalities, most frequently strabismus, which may be related to the low muscle tone that these kids have. A lot of kids have gastroesophageal reflux, and many of them are treated with medications. Some of them have required surgery with a Nissen funduplicatio to take care of the reflux if it's fairly severe. And a lot of these kids have difficulties with temperature regulation. So you may realize that a lot of these features are also present in children with Prader-Willi syndrome. So this is a diagram that I think I generated when I first presented at the FPWR conference in 2013, and I keep modifying it. I even keep modifying it throughout my talk today. So there's a lot of overlap, and I think the overlap between Prader-Willi and Schaaf-Yang syndrome from a clinical standpoint is the low muscle tone, which is particularly pronounced at the time of birth. Feeding difficulties, a lot of kids need extra help with feeding, which can be as simple as a special nipple, or they may just take longer, but many of them also need tube feeding. Almost all of them have developmental delay and intellectual disability. I'll tell you a little more about that. And the underdevelopment of the gonads, especially the undescended testicles, is something that we realized early. The hyperphagia, the obesity, and some of the typical Prader-Willi-like facial features, we don't tend to see as much in Schaaf-Yang patients. And then on the other hand, for Schaaf-Yang, two things that we realized very early were the contractures, and then also we felt that there was an extremely high prevalence of autism spectrum disorder. I know that there's a good number of kids with Prader-Willi who have autism or carry an autism diagnosis, and some of them may not carry an autism diagnosis, but they may still have features that could go along with autism, such as obsessive-compulsive behaviors and speech impairment. But the prevalence of autism in Schaaf-Yang syndrome seemed to be much higher. In Prader-Willi syndrome, most of the studies will say about 20 to 25% of kids meet autism criteria. It seemed that in our cohort, it was more than 70, 80% of our kids. In fact, all of the kids who we had come to Texas Children's to go through very rigorous assessment for autism, all of them met criteria for autism. So this is just another way to look at it. Almost all kids have developmental delay, but they tend to reach their developmental milestones, like sitting up, walking, talking, but just kind of at later times than your average child. Intellectual disability is present in about 90% of the patients with Schaaf-Yang, and autism spectrum disorder at least in 75% of our patients. Through a study that was funded by FPWR, we enrolled 10 individuals with Schaaf-Yang syndrome. At that time, we were aware of about 40 in the world, and we enrolled 10 and had them come to Texas Children's Hospital to go through very rigorous phenotyping with IQ testing and autism testing, and then additional studies looking at their hormone status and imaging, bone mineral density assessments. And I'm going to present some of these data here. They're not published yet, so you won't find them if you look on the internet. The cognitive testing, surprised us, and I think this is something that I wasn't really aware as I started looking at these children. There is a fraction of these children who are particularly low functioning. In Prader-Willi syndrome, most of the kids have mild intellectual disability with IQs between 50 and 70. There are some who have higher IQs, up to the 90s or sometimes even 100s. And then there are some who have moderate intellectual disability with IQs lower than 50. But that's kind of the region where most of the kids are when they tested. In the Schaaf-Yang patients, so here I'm plotting the 10 patients who went through our study. You see that there are a few who have high IQs, and then many who are in the moderate range with IQs in the 40s. But then there are also these kids who have IQs in this study of 15, 3, and 1. So very, very low functioning. We would consider this profound intellectual disability. And this is something that, at least to my knowledge, is very rarely seen in the Prader-Willi community. So it's intriguing to me, and certainly something that we'll continue to investigate, why there's a subset of patients that are so low functioning when it comes to their cognitive abilities. And I have some ideas, but we will need to look into that further, whether there are certain modifiers that predispose them to be particularly low functioning. And then as part of that study funded through FPWR, we also wanted to look into the endocrine system. Now, this is something that obviously in the Prader-Willi community has been looked into for a long time. And it's known that especially the hypothalamus, which is kind of the master regulator of the endocrine system, doesn't really fulfill its function in a way that it should be. This is important because we also know that the MAGEL2 gene is specifically expressed in the hypothalamus. It's the one brain region where there's the highest expression of this gene. And so it made a lot of sense, based on the knowledge from Prader-Willi syndrome that, there's an overrepresentation of growth hormone deficiency, kind of abnormal sexual hormones often. Many kids have hypothyroidism. A lot of kids struggle with glucose tolerance. There are abnormalities of certain hormones that are related to feeding behaviors. So it made a lot of sense to look at these to better understand what are the similarities and what are the differences between Schaaf-Yang syndrome and Prader-Willi syndrome. So again, these are unpublished results, but these are the 10 patients who came through our study. What you see on the left is an assessment of hormones or molecules that are related to growth hormone metabolism. And you will always see the normal range in the gray colored bars, and then the black dots are the values that our patients have. So, without even looking at the numbers, you see, especially on the top left, that most of these black dots kind of fall outside the normal range. This is the assessment of IGF-1, and IGF-1 is something that relates to growth hormone, and low values of IGF-1 indicate that there may be a growth hormone deficiency. It's kind of like a screening tool that we use to look for growth hormone deficiency. On the bottom is IGF-BP3, so IGF binding protein 3, and even though many of them are in the normal range, some of them also really tend to be on the lower end. This is a distribution that is quite similar to what would be seen in kids with Prader-Willi syndrome. On the right side, we're looking at ghrelin. Ghrelin is a hormone that is known to play a role in in feeding behavior, in eating behavior, and in appreciation of satiety. So as we eat and the stomach kind of gets bigger and fuller, ghrelin is released to kind of get us to stop eating. And it's long been known that ghrelin levels are abnormally elevated in children with Prader-Willi syndrome. Now, this is a huge surprise to me because this is certainly not what I expected. Based on my understanding at the time, I felt that the hyperphagia was a feature of Prader-Willi syndrome, but was not seen in most of our kids with Schaaf-Yang syndrome. So I actually expected that we would not see the elevations in ghrelin in this patient cohort of Schaaf-Yang syndrome, but they do. So you see that out of the 10 patients, 9 have abnormally elevated ghrelin levels, both at the fasting state, and then we give them a meal, so to say, and then we measure that again a few hours later. And while for many kids, the ghrelin level goes down, for most of them it's still abnormally elevated. So this is quite intriguing, and I don't know yet, what to make out of it. But by talking to more and more of the families, I also get to understand that while these kids may not have the aggressive food-seeking behaviors that are typically described in Prader-Willi syndrome, at least when you read medical textbooks, in Schaaf-Yang syndrome, it seems that many, if not most, of the children do lack the appreciation of satiety. They will not feel full, and they would continue eating if you let them. On the other hand, very few children will, actually get up at night and go to the kitchen cabinet and kind of, eat voraciously whatever they can find, even though there are some kids who do that. And it seems that in particular, some of the higher functioning kids, those who have the higher IQs, are some of the ones who, get around the system and get to go and find the food, versus the lower functioning kids are the ones where, the parents are basically in full control of how much they get. So I think we have to rethink about this idea that hyperphagia is something that's unique to Prader-Willi syndrome and not present in Schaaf-Yang syndrome, because some of the underlying mechanisms may actually be the same. We also looked at glucose intolerance. So we had the patients fasting. This is similar to when you have like a glucose tolerance test when you're pregnant. So we had them fasting, we measured glucose, we gave them a dextrose drink, and then 2 hours later, we looked at the glucose again, and you can see that several of the patients, these are all kids between 5 and 18 years old, do have abnormal glucose tolerance because they're not able to regulate that glucose level appropriately. One of the patients actually is known to be diabetic, and she had a fasting glucose that was elevated, so we couldn't actually perform the glucose tolerance test. So that's that one little black dot that you see up there. And then we also looked at some sex hormones, including LH and FSH, which are hormones that are released through the hypothalamic pituitary axis, kind of from the master regulator of the endocrine system. And many of these values are still within the normal range, even though many tend to be on the lower side. So I'm not quite sure yet if the hypogonadism, in fact, it's called hypogonadotrophic hypogonadism. It's like one of those long words that you have to go to medical school for 6 years so that you can pronounce it. I don't know if that's truly present in Schaaf-Yang syndrome or not. I mean, I've told you about the undescended testicles in the boys. We have some girls, especially who are in their teenage years, who seem to go into puberty normally, and they have their menstrual cycles normally, and their sex hormones are within the normal range. So this is something that we need to follow. It's also a question of whether the system is able to maintain appropriate levels for a certain time, but then whether it may burn out over time, and if these girls especially may go into menopause early. There are several things that we don't know yet, and I'm not an endocrinologist, so for a lot of this I rely on Jennifer Miller, who's sitting back there, because she's obviously much more knowledgeable than I would be. We also looked at the bones, and scoliosis is something that Rachel Veverick asked me one day as we were talking about MAGEL2, because from her studies in the MAGEL2 knockout mice, when she takes out MAGEL2 from the mouse, she noticed that these mice develop kyphosis and scoliosis, so abnormalities of the spine. And I said, I have no idea. I've never asked these patients about scoliosis, and I should start looking into this. I think at that time we only knew about 10 patients or so, and it's simply something that I hadn't asked. So scoliosis is present in many of these children, and it can be mild to moderate, but sometimes it's also severe. So we have, even some infants who already have scoliosis of 50, 60, 70, 80 degrees. So I think some of the families were really thankful to get a chance to listen to Dr. Van Baarse today and his presentation, and maybe in touch with him. We also looked at bone mineral density and did DEXA scans, which typically you can do when the kids are 5 years or older. We were able to show that many of these children have very low bone mineral density, especially in the hips. And so this is measured in Z-scores, which are standard deviations from the normal. And everything would be considered normal. That's between -2 and +2. But a lot of these kids have -4, -5, sometimes even -7 or -8, which is, an indicator of osteoporosis. In fact, if you have a Z-score that's less than -3, that's considered osteoporosis. So these kids are at risk for abnormal fractures. So even with minimal trauma, they could easily fracture, their femoral head or, their hip bones. And this is something that we need to follow. We also know that in the MAGEL2 knockout mice, again, they also have osteoporosis. So we know that it's connected. It's not just a coincidence that we see this. And it's probably not just related to a hypomobility, them not being able to stand and walk on their legs and do weight-bearing exercise, but it's probably something that's causally related to the MAGEL2 gene. And we're looking into ways as to how best we could treat this. So here I have like a modified Venn diagram showing that we can add to this area of overlap between Prader-Willi and Schaaf-Yang syndrome. There's not only developmental delay, hypotonia, feeding difficulties, but also I've now shown you that there also seems to be growth hormone deficiency, high ghrelin levels, osteoporosis, and scoliosis, both of which are seen in both conditions. Now, something that's quite different from Prader-Willi syndrome, there are typically no familial cases of Prader-Willi syndrome. So each one of you, has one affected child with Prader-Willi syndrome, but it's not like you also have a cousin and another cousin and, an aunt and someone else who has Prader-Willi syndrome. Usually those are simplex or isolated cases. For Schaaf-Yang syndrome, we're in touch with several families who have multiple affected individuals. Some families, like the bigger one on the bottom, which from Europe, with 14 affected individuals, across several generations. And that is because of the unique nature of the mutations that these kids have. You can carry these MAGEL2 mutations as long as you get it from your mom. So as long as this mutation runs through the maternal line in a pedigree, there could be many generations being unaffected. Only once, a male is a carrier of the MAGEL2 mutation and passes it on to his children, then that child would be affected. Am I getting signs that tell me that I'm going over time? Okay. So I only have like 2 or 3 more slides. In collaboration with Ryan Potts, we've tried to also understand the function of MAGEL2, and we propose that some of its interaction partners may also be related to neurodevelopmental disorders. So we know that MAGEL2 works very closely with 2 other proteins, TRIM27 and USP7, and we were able to identify individuals who have USP7 mutations, and they actually have a medical condition that is, again, related to Schaaf-Yang syndrome, and by that, it's also related to Prader-Willi syndrome. So these kids with mutations in the protein that interacts with MAGEL2 have developmental delay, intellectual disability. They have a high prevalence of hypotonia, eye abnormalities, autism spectrum disorder, feeding difficulties, undescended testicles, hypogonadism. There's one thing that seems to be quite unique about them, is that most of them have abnormalities on the brain MRI that are quite distinct, that specifically affect the white matter. So there's a loss of white matter, and then also the white matter looks abnormal on the MRI. So I think this is, for me at least, this is an amazing example of how we can understand certain disorders that are connected to one another from a molecular standpoint. They all have to do with one another molecularly, and then that translates into a relatedness that we can see clinically as well. But then obviously, you know, the USP7 gene has functions that are outside of the interaction with MAGEL2, so it's not surprising that these kids also have features that are unique to that group of disorder, and that the MAGEL2 kids may have features that are unique to that group of disorders. And I also, you know, have to be aware that this diagram will never be perfect. So Teresa and I just talked about this earlier, that there are more kids now with USP7 mutations where the parents report hyperphagia. So I keep modifying this slide, and if I get to give another talk in 2 or 3 years from now, I'm sure that it will look different again. But we are learning a lot about these disorders from you guys. So this gets me back to the question, which gene causes Prader-Willi syndrome? I don't know. You know, I'm not here to tell you that it's all about the MAGEL2 gene. Obviously, that's my bias because, you know, I've spent a lot of time thinking about MAGEL2. But I think it's clear to me that it's not just MAGEL2. Prader-Willi syndrome is most likely the result of the effect of multiple genes and RNAs within that locus. And some of them may actually have to do with one another. For example, we know that nectin, which is another gene in the locus, interacts with MAGEL2. And there's evidence that maybe the SNO RNAs regulate, you know, the stability of some of the proteins that are also expressed. So it's complicated and, you know, gives us more things to do. So at least it's not getting boring for us. So in summary, I try to convince you that point mutations in MAGEL2 cause Schaaf-Yang syndrome, which is molecularly and clinically related to Prader-Willi syndrome. We can all learn from each other, and I'm extremely thankful for that. And something that I didn't go into, but that will be the subject of a lot of future research, is that I believe that the therapeutic approaches may also be similar. And so the Schaaf-Yang families are in a very lucky position because a lot of research has gone into that in the Prader-Willi syndrome field. So we are learning from you guys, and some of the things that we will consider are growth hormone therapy and others. So with that, I'm closing, and I'm just showing a picture of my lab, and I have a new research coordinator who also works with the Schaaf-Yang families. Her name is Megan Reach. You have our email addresses. You can always send us an email if you have a question. And we also made new flyers summarizing the features of Schaaf-Yang syndrome, and there's another handout that explains like the details about the chromosome 15 and the maternal and paternal thing. Both of those can be found at the registration desk outside, so if you're interested, just come by and get one. So thank you very much.